Today we shall discuss geometry. Yes, geometry is an aspect of mathematics that deals with different shapes. It involves angles, parallel lines, polygons, and circles. Yes. Now let's look at the first one, angles. An angle is a measure of rotation. Yes, if we have something like this, this is, let me take this, and if I rotate the first biro, this is the blue pen, then the space here, the amount of rotation here is what we call angle, or the measure of this rotation is an angle. Okay, yes, so angle is a measure of rotation. Angles are measured in degree. Yes, this is the sign of degree, and with instruments, the instrument used in measuring angle is protractor. So angle is measured with a protractor. So this is the instrument that you can use to measure angle. Angles are formed when straight lines meet. Yes, when two straight lines meet, so an angle is formed. Like we have line AB and BC. Two of them meet at this point, and an angle is formed here, and this angle is 92 degree if you measure it with protractor. Okay, so let's measure it. Okay, so this is we start from here, and this is 90. We count 91, 92. Yes, the value of the angle here is 92. Now look at another two straight lines here that meet at a point. Look at here, this is XY and XZ. Two of them meet here, and an angle is formed here. Okay, yes, names of an angle is determined by their sizes. So names of angle are determined by their sizes. Like we have acute angle. So this acute angle is any angle that is less than 90 degree but bigger than 0. So any angle that lies between 0 and 90 degree is called acute angle, like angle 30, angle 35, angle 60, angle 75, angle 80. They are called acute angle. Yeah, this is an example of acute angle. The angle here is 50. Yes, if you measure this angle here, it is 50, and because of that, we call it an acute angle. Okay, so let's measure this angle. Okay, so we start from here. This is 0, 10, 20, 30, 40, 50. So this angle is angle 50 degrees. So it's an example of acute angle. The next one we have here is right angle. Now the one we call right angle is an angle that is exactly equal to 90 degree, and we normally use this sign to represent right angle. And this anytime you see this sign in a shape or in any diagram, know that the angle in that space is 90 degrees. So this sign, which is called square meter, is what we normally use to represent 90 degree. Then the next one we have here is obtuse angle. Yes, obtuse angle is angle that is between 90 degree and 180 degree. That means any angle that is bigger than 90 degree but less than 180 degree is called obtuse angle, like angle 120, angle 101, angle 98, angle 110, angle 150, angle 175. All these angles are obtuse angle because they are less than 180 degree and bigger than 90 degree. Okay, now let's measure this angle and see the value. If we want to measure this angle, the baseline of this angle that I want to measure, I will allow it to coincide with the baseline of this my protractor, and this point of this point where these two lines meet, I will also allow it to meet with the point where this horizontal line of this protractor, this vertical line of the protractor and the horizontal line, this point where they meet, I will allow it to meet on this our own point here, this junction point. Okay, so let's measure it. Okay, so from here now let's count. We have, this is 90, this is 100, this is 110. Yes. Okay. No. Okay, this is 112. Yes, the angle is 112. We have 110 here, which is this point. This is 111, 112. Okay, so the value of the angle is 112. Yes, and because it is bigger than 90 degree and less than 180 degree, is an example of obtuse angle. Okay, the next one we have here is reflex angle. Yes, reflex angle is angle that is less than 360 degree but bigger than 180 degree. In other words, the reflex angle lies between 180 degree and 360 degree. So example of reflex angle, we have angle 189, we have 200, we have 350. Yes, even angle 270 is a reflex angle. Angle 220 is a reflex angle. So any angle that is bigger than 180 but less than 360 degree is an example of a reflex angle. Okay. Now the next one we have here is angle at a point. Now remember, we have been rotating. Let's start from the first one we mentioned, acute angle. Okay, this is acute angle. Initially, the line, before we move over to acute angle, we have a line here. And I am taking these two lines that, I am taking this line here to be two lines that overlap each other here. So you cannot really see the next or the second line here. Now, if I move the first line, I will now get to this point. So like I said, what I have here is, in this place, is a line that is like this. A line that is like this. So you cannot actually see the next. I'm looking at this place. So I have a line that is like this. So if you don't check very well, if you don't look at us, check very well, you will not see the next line until I rotate it this way. Okay, that is what I have here. Okay, so I have two lines here that overlap each other here. So if I move the upper one, then you will not see it here. So look at the upper one is now, I have moved it here so that I cannot measure the extent of rotation. And here the extent of rotation here is 50 degree. Okay, now if I keep moving this line, now let me move it to this point so that it can now come and stay here, which is what I now have here in a right angle. So you will see what is going to happen here. Now look at it here. Now I want to adjust this line again, to now come somewhere here. So look at, so if I adjust this line to be here, now look at it here now, which we now call obtuse angle. Okay, now I want to rotate, I want to adjust this line again to come down somewhere here. This line, I want to adjust it to come down somewhere here. Okay, so look at it here. The line have moved from here like this. It is now at this point here. So look at where the line is. Okay, so you can see the thing has rotated to this point here. Now this angle is now reflex angle. Remember, the angle is not yet up to 360 degree. Now I now want to finally take this line, back to where I brought it before. So I want to take this thing back to this place. So now it can now come over here again. Okay, so look at it here now. So the line has actually moved from this place, from here like this, and return back to the former place from the initial point. Now the angle that is formed when this line moves from here and return back is called angle at a point, and the value of angle at a point is 360 degree. Okay, and when something moves round like this, when something moves round starting from this place, move round and return back to that point where it started its journey, we call it a revolution. So this is one revolution. So one revolution has an angle of 360 degree. So the value of one revolution is 360 degree, and the value of angle at a point is 360 degree. So this is called angle at a point when a particle or a line has completed one revolution. We call it angle at a point, or angle in a circle. The value of angle in a circle is 360 degree. Okay. Now the next one we are going to discuss here is straight line angle. Straight line angle, yes. Straight line angle is an angle that is formed on a straight line. Yes, and the value of angle that is formed on a straight line is 180 degree. Yes, sum of angles on a straight line is 180 degree. The value of angle on a straight line is 180 degree. Okay, let's see how to know when two or more lines are on a straight line. Now, for us to know whether a line or two lines are on a straight line, we will first of all check to see if we have a baseline. Like in this first one, we have a baseline. So this one is the baseline. And these two lines actually meet here. And two of them meet on this baseline. So because of that, I will now say that these two lines, they are on a straight line, on this very straight line. So any angle they formed on touching this line, we'll call it angle on a straight line. Yes, any angle these two lines form on touching this very baseline, since two of them meet at the same point here, so we can now call it angle on a straight line. So that means that A plus B plus C will give us 180 degree, because sum of angles on a straight line is 180 degree. Okay, now let's look at this one. Now this one, look at, we have a baseline. Look at it here. This line is the baseline, and this line also actually meets on this baseline here. Okay, so because of that, we will say that this very line is on a straight line. Look at the straight line here. This very line, this one with arrow, is on a straight line. This straight line, look at the baseline here. So any angle this line form on this one, we now call it angle on a straight line. So this line on touching this very baseline here formed two angles, which is D and E. So like we said, sum of angles on a straight line is equal to 180. So these two angles, angle D plus angle E, will give us 180 degree. Okay, let's look at this one. Now if you watch very well, you will discover that this line, there is a line here, actually meets this line here at a point here, at this point. So because of that, as far as this line is concerned, this very line coming here is not a baseline because two of them meet at the same point here. It's not like this one. It's not like this one. This one touch this line here. It's not like that. But this one, this line and this line, the two of them meet here. So no one is taken as baseline. So because of that, we cannot say that angle F is on a straight line. Okay, let's look at this one. The same thing is applicable to this place. This very line here and this line that is on red color actually meet at this point here. So because of that, we will not call it angles on a straight line. So F and G cannot said to be angles on a straight line, okay? Because there is no baseline in these angles that is formed here. Instead, we can call it angle at a point because these two lines meet at a point to form their angle. So these two lines meet at a point to form their angles. And angle at a point, the sum of angle at a point is 360 degrees. And that point is this angle, an angle that is going to form from here like this to this place. So any angle here plus this F will give us 360 degrees. The same thing is applicable to this place. Since two of them meet at this point here, the angle we can use on this G is angle at a point, and that angle at a point includes this one and any other angle that is around this place, okay? Now let's look at this one. Now in this place, we have, okay, you need to pay attention here because if you watch very well, these two lines, now look at these two lines, this one and this one, these two lines, two of them are baselines. Why did I call them baselines? If you watch very well, if we consider this very one, on considering this very line here, this very line reach here and crosses. So because of that, this line is a baseline to this one. So we can now say that this line on touching here, like as if this line touched this one here. So that is how this line is. This one touch here and pass. But this one touch here but did not pass. So only form angles on a straight line above here, only this place. But look at this one reach here, touch here, and pass. Because of that, on getting to this place, it forms an angle on a straight line at here and here, just like this place and this place. Now, when it passes here as well, it forms another angle on a straight line here and here, just like this one, but upside down, okay? So that means we have angles on a straight line, two here, H and I, they are angles on a straight line, and also J and K, they are also angles on a straight line. Now, I am through with this very line. Remember, I told you that these two lines, this one and this one, two of them are baselines, okay? Now, if I consider this one to be my baseline now, so you now see that this very line actually meets this line here and crosses as well. So when this line gets here, it forms two angles, this one and this one, just like this one meeting this one here to form this angle, this angle D and angle E. So when this one actually meets this line here, it forms two angles, angle H and angle J. And when this line crosses as well, like this place now, it forms another two angles here, angle I and angle K. So we can now say that taking this line to be the baseline, we have angle H and angle J to be on a straight line. So these two angles, you can say angle H plus angle J is equal to 180 degree angles on a straight line. The same thing is applicable to this one. Angle I and angle K is angles on a straight line. Okay, so two of them sum up to 180 degree. Okay, fine. Now, another thing we can use here is considering these lines like this one to be a different line from this one. That's from this line from here to this place to be a different line from. So this line from here to here is taken to be a different line from this line from here to here. So I can label it to be, I can call this line from this line from here to here line line AB. So this is line AB. This line from here, this is A, here is B. So now this, and we have angle line, we have line CB. Remember, we have splitted these lines now. So we now have line AB, line CB, line DB, and line EB. And all of them meet at this point here. So since we have now taken these lines to be different lines, like all these lines we mentioned, BD, BE, BA, BC, and all these lines meet here. So we can now consider all these angles formed here to be angle at a point. Now we cannot take them to be angle at a point. So from there, what it means is that when we see two lines that crosses this way, like this one and this one, the angles formed there can be all taken as angle at a point. Okay, now look at another one we have here, like this one. Now you see this one is almost, in fact it's the same thing as the previous one. So we have this line here, this one in blue ink, this one crosses this one in black ink. So because it crosses here, it now form, on getting to this point, before it cross, on getting to this point, it form angle Q and P. Now when it crosses, it now form angle R and angle S. So angle Q and angle P can be taken as angles on a straight line. So angle Q and P sum up to 180 degree. Also angle R and angle S sum up to 180 degree. But when we take or consider all of them, because this line crosses this one or this one crosses this one, we now call it angle at a point. Okay, let's look at this one now. Now in this place we have several lines here. Remember, we said that an angle is formed when two or more lines meet. So that is why I always talk about lines. So we have this line here, this one in blue ink, and also this line here. So we have these two lines meeting at this point here. Now if you watch very well, as far as this line and this very one is concerned, no one is a baseline. So this one is not a baseline to this one. What I mean by that is that this one is not like touching this line in between, like somewhere here. Now, but the two of them meet at a point here. So these two lines are not like the first one. The first one we have here, where this one, touch this line in between somewhere here. Or this one, where this very line touch this line in between. So this one, had it been this one touch this very line, had it been this line here, this one with arrow touch this very line at this point here, I would have considered it as angle at a point, not angles on a straight line. But because this one touched this very line on this point here, so I can now say that D and E are on a straight line. But if this line is touching this one at this point here, so it will no longer be angle on a straight line. So instead it will be angle at a point. Okay, so let's look at this one. So that means that this line and this line that form angle L is angle at a point, not on a straight line. So that means angle here plus any angle here will give you 360 degree. Okay, so if we have here, like if we have an angle here, maybe this angle is A, we can now say that A plus L is equal to 360 degree, because two of them now is angle at a point. Two of them form angle at a point, okay, at this point. Now let's look at this place. Now this line actually meets this very line here. So that means that this very line here, this one on a red ink, has formed a baseline to this very line. So that means that any angle this line form on this red one is going to be considered as angle on a straight line. So M, angle M, and any other angle here, and any other angle here. So if we call any angle here, let me call it alpha. If I call any angle here alpha, then I will say that alpha plus M is equal to 180 degree. Alpha plus M will give us 180 degree. So because in this place we now say that M and alpha form angle on a straight line, so which is 180 degree. Now let's look at this place. This is, we have angle N here, and this angle N is formed by the meeting of this these two lines, this one and this one. Now since this line actually meets this very other line at this point here, so this one, none of them is a baseline. This one is not a baseline to this one, and this one is not a baseline to this one, because two of them meet at this point here. So we will consider this point, this angle here, with another angle formed here as angle at a point. Okay, so if we have an angle X here, so I will now say that N plus X is equal to 360 degree, because angle at a point sum up to 360 degree. Okay, now like in this place now, if I don't want to consider Q and P to be angle on a straight line, I can now say that this line meets here, and this line meets here, this other line meets here, and this very line meets here to form all these angles. So since one and this since line, this one, this line, and this line, and this line, and this line now all meet here, now we can now call the angle formed here angle at a point, which now mean this one, since we are considering angle at a point, we can now say that Q plus P plus R plus S is equal to 360 degree, and this is the reason is what we call angle at a point. Okay, it's time for our TYA, test your ability. So I want to test your ability based on what we have learned so far. Yes, so it's time for TYA, testing your ability. Okay, you will help me answer this question. Now, from the angles here, so look at this, we have angle A, B, C, D. Now we have options here, so I want you to tell me which of these options is or are correct. Which of them is correct, or which of them are correct. If we have two options that are correct, you can indicate. If it's only one, you can tell me the particular one that is correct. Okay, let's look at this thing now. So we have the first one that says A plus B is equal to 180 degree, and our reason is angles on a straight line. So let's look at A plus B. A plus B. So if you watch very well, A plus B, they are not like the those ones we have seen before. Okay, A plus B is not like this one and this one, or D and E. They are not like that. D and E are angled on a straight line, but A plus B is like M and N, and M and N, they are not angles on a straight line. Instead, M and alpha are angled on a straight line, and N and M and alpha, they are angles on a straight line, but N and X, they are angles at a point. So A and B is not like that. So look at it here. A and B, they are not angles on a straight line. So the first one is wrong. This one is wrong. Now let's look at the other one. B plus C is equal to 180 degree angles on a straight line. Let's look at B plus C. B plus C is the same like A and B, so they are not angles on a straight line, so that one is wrong as well. Okay, let's look at the next one. A plus C. A plus C. A plus C. A plus C is just like A plus B, the first one we saw. So A plus C is not correct. So this one is not correct. Okay. And then the next one we have here is C plus D. C plus D is equal to 180 degree angles on a straight line. C plus D. Okay, yes, if you check very well, this line actually meets this line at this point here. This line meets this very line at this point here. So that means that this line is a base line to this very line. And because this line is a base line to this very line, now this line form an angle at on a straight line. This line now form an angle on a straight line. So C plus D is equal to 180 degree because there is angles on a straight line here. So that one is correct. So C plus D is equal to 180 degree angles on a straight line. This one is correct. Okay. Now the next one we have here is A plus C plus D. Okay, let's look at it here. A plus C plus D is not correct because A and C, they are not angles on a straight line, but C and D are angles on a straight line. So this one is wrong. This one is wrong. Okay. Now we have another one, A plus B plus C. Okay. A plus B plus C. Let's check it there. A plus B plus C is equal to 180 degree. Actually, we have what we call sum of angles in a triangle. This is angles in a triangle. It's actually 180 degree, but the reason here is that they are angles on a straight line. A plus B plus C equal to 180 degree is actually true, but based on our reason here, angles on a straight line is no longer true. So this one is not true. Again, based on our reason, it's not true. So this is wrong. It's not true. So A plus B plus C is 180 degree, and the reason is sum of angles in a triangle, not angles on a straight line. Okay. Now let's look at number 2. Okay, we have the second one here. So we have the second one here. So what we are going to do now is you are going to consider this question. We are looking at the one that is correct here. So I want you to pause the video and solve it, and wait for me to solve my own. Then you now check whether you got your own answer. Okay, and let's now solve it together. Now look at the first one. We have A plus B is equal to 180 degree angles on a straight line. We have A plus B. A plus B. Yes, A plus B is angles on a straight line. So it's correct. It's correct. That one is correct. Then we have the next one, A plus B plus C equal to 180 degree angles on a straight line. Let's look at that one. A plus B plus C. No. A plus B plus C, because this line, this very line, is now on the other side of this baseline. This is a baseline to this very line, and actually this one is also a baseline to this one, but this one is on the other side from this one, so we cannot consider C, A, B to be on a straight line. If we must consider C, then we are going to consider C as angle at a point, considering all these angles now. So we will just consider all these angles to be angle at a point. So A, B, and C is not angle on a straight line. Okay, so this one is wrong. This one is wrong. Then the next one we have is C plus D plus E. C plus D plus E. Okay, C plus D plus E. Now look at what we have here. This is a baseline. Okay, now we have this line as a baseline. So we are looking at this side where we have C, D, and E, not this side. So we are no longer looking at this side. Look at the side we are looking at. This side we have C, D, and E. We want to know whether C, D, and E, they are angles on a straight line. Okay, fine. Now, since this line meets here and it did not cross, this line also meets here and it did not cross. Now, two of them meet at a point here, but on a straight line. So this one is a straight line. So this one is a baseline, a base straight line to this one and even to this one. So this line and this line meets on this straight line here. So here meets this straight line here. So because of that, we can now say that C, D, and E, they are actually angles on a straight line. So C plus D plus E will sum up to 180 degrees, and the reason is angles on a straight line. So that one is correct. Okay, this one is correct. Okay, I hope you are following it now. Okay, now let's look at the next one. The next one is C plus E plus F. Okay, C plus E plus F. That one is wrong because F is now C and E, they actually form here, but F is actually on the other side. F is formed when this line and this line meet here. So F cannot be taken as angles on a straight line with E and C. So that one is wrong. This is wrong. Now let's go to E plus F. E plus F. E plus F is not also angles on a straight line. It's wrong. Now we have A plus B plus C plus D plus E is equal to 360 degrees. So let's look at it here. A plus B plus C plus D plus E. Now actually these lines, all of them form angle at a point. They form angle at a point here. So it's true. They sum up to 360 degrees, and the reason is angles at a point. This is what we have here. Angles at a point. We have point here. So that one is also correct. Okay. So look at this question very, very well. And before you solve it, go back to what we have learned. Look at them very well, study them very, very well, and try to solve this question. Now, when you are done with that, you can send your answer in the comment section, okay, for me to see how far you have learned this topic. Okay, thank you very much. And don't forget to jot all these things that we have learned today. Don't forget to jot them.